Hello guys, and welcome to another video in the Inner System Analysis Python course. My name is Anas Abuzayed, and in today's video we will talk about functions. So a function is a block of code that is only run when you call it or when you execute it. A function can have different arguments, different inputs, different structure inside what's happening inside a function, and it's a very useful tool in Python. So how to define a function in Python? By using DEF. So whenever you start DEF, is you're telling Python, I'm starting a new function. So first you need a function name, and then in brackets, you can put your arguments or your inputs, your data that you want to work with. And here you have the body of the function. It's a body of the function that basically executes something or prints out something, whatever you want, and then you can return a value on it. So let's say you return the data after you manipulated it, or the list after you changed it, or something like this. So let's start defining a normal function. Let's say we define a function that says print, and then here we say print hello from function. So if we define our function, now to call it, just print, and then basically execute it. If I run it from scratch, it will print out nothing. Why? Because the function is also only executed if you call it. So if this one here was removed and you select everything and run it, nothing will happen. So let's try to define a function that can give us the square of a number. So let's say left square, and then here we have the number. So if in order to return something out of a function, we have to use return. So either I say return number times number, which is the square of the number, or I define here a variable, let's say v equals number times number, and then I say return v. So let's try it out, and then I say square, so I call the function. Now here I say v equals 7, then I'm sorry, not v, number equals 7, then it will print out 49. Why? Because I retain the value out of it. If I say a equals this function with the input 7 into it, if you see here, now a equals 49. So it's very important to note here that the inputs and whatever happens in the function itself. So normally when we say v equals, let's say 7 to the power of 2, we define v here. So we will see it in our variable explorer. However, if we remove this one and again try to run it, say it will give us that it is not defined. So whatever variable name that you use in here does not apply or does not identify inside our code. So an important thing to deal with when we talk about functions is that whatever we send to the function, say here we send an integer. Inside the function, it will also be dealt with as an integer. So if we try to say square number equals 7, this will give us an error because 7 is a string. So it's very important. If we send it as a list, it will be dealt with as a list. If we send it as a dictionary or a tuple or whatever you want, it will be dealt with the same way. So let's try to define a function where we send a list to this function and it will give us back the mean. So we saw from previous videos that there is no built-in function for the mean. So let's try to define one. So first we define a list, a normal list, a random list. So let's say 2, 6, 9, minus 20, and 55. And then I want the mean of it. So the mean is basically sum of A over length of A. But if I want to define a function there, I have to say def, and then I call it whatever I want to call it. So I'll call it mean. So here, my list, or let's say my list, and then return sum of my list over the length of my list. So now if we say mean of A, this will give us the average of this list. Let's say I say mean of 55, 77, 88, 0, and minus 40. So if I run this again, it will take this list that we did not define, but we just put it as an input, and then it basically executes it. So if we say that we have a list, for example, instead of 0 here, we put a string. So here we expect an error because you cannot sum a list of non-numerical values. So let's try to define a function, for example, to calculate the MAPI, so the mean average percentage error. Statistical ways to calculate the error between an actual or forecasted data frame or data sets or two different data sets. So let's say we say L1 and L2, and then we want to calculate it. Let's say the return is something. So let's define a new or two lists. Let's say one is actual. Let's just put different voltage levels, and then we have a forecast. We want to calculate the MAPI for them. So here, it's important to note that whenever we call the function, let's say we want to put or to input the actual and the forecast data or lists here into our function, they will also be dealt with as lists. So here we want to calculate each time how much is the MAPI for this list. So in order to do this, we need a for loop. So we need a variable here for the error, let's say 0. And each time we want to iterate over those two lists and calculate the MAPI in each time. So let's say we want to make a for loop here and over the two lists. So how to do it? Let's say IDX and for actual, for forecast, and enumerate. So let's just try it out to see if it works. IDX and F. So here A stands for L1, F stands for L2, and the IDX is basically the index. So each time we want to say error plus equal, we set the actual minus the forecast over the actual. So A minus F over F. And each time adds it on top. So what we want to return here is our error. So let's define this function and then say, okay. The actual, so let's say L1 equals actual, and then L2 equals forecast. What we forgot to say here is that the MAPI is basically an absolute value. So here in our definition, we should add an absolute. So it cannot be a negative value. And in order to make it either easier, either we multiply by 100 here or 100 here. So it's the same. So if we say times 100, and then we need an average. So in order to have the average of it, so in this case, they are 5, so this needs to be over 5. But let's say if our list was 7 or 8 or 20, so in this case, our definition would be wrong. So over the length of L1. So if we calculate it now, let's say define our function, and then our actual and forecast, and then we have roughly an average error or absolute error, sorry, of roughly 1%. So defining the functions, there is different things that you need to take care of. For example, if we say the same without L1 and L2, what will happen is it will take the actual, let's say as L1, so it will follow the same order that you define it. But in case, let's say it was the other way around. So instead of this, we say actual. So one thing is that if you do it like this with only one list, you will get an error. Why? Because it's not getting it. So you define two arguments, you need to put two arguments. So now if we say the mapping of this one, what will happen is that forecast will be L1 and actual will be L2. So either you put them with the equality, so assign them, and if you assign them, you need to follow. So if you say MATE, here you will see it that L1 and L2. So either you follow the same, then in this case, you don't need to say L1 equals or L2 equals. If you want to change it by saying L2 equals forecast, L1 equals actual, that is not a problem. But if you don't put it with L1 equals or L2 equals, it will follow the same order that you put here. So here it's again roughly 1%. So the same that we did before. So in summary, the order does not matter if you assign them, but it matters if you do not assign them. So let's go a bit further. Let's say we define a function, a normal function, say country, and then you say, I want to print basically, or to have a definition where it says where I am from. So I want to say print, I am from, and in this case, my input will be this country. So if I want to use this one, and I say Germany, then it will basically use it and say the same. Let's say Italy, so it will change. But what happens if I define a default one? So for example, if I say a default country, for example, is Jordan. Now, if I use, or if I assign something here, the default value will be gone. So if I use it like this, the default value Jordan will be gone. But if I use it without the default value, let's say only like this, without assigning anything, then the default value will be here. So let's say you define a function for a power plant or something, or a bunch of power plants, anything that you want to define. You can have a default value. For example, let's say if you want a function to calculate or that uses a power factor to use or to do some electrical calculation or some calculation, you can define a normal power factor, let's say 0.5 or 0.7 or 0.9, something like this. Of course, not more than one, but you can have a default value that will be used in your calculation. In case the user or let's say the interface did not enter any other value, then the default value will be used. Other, let's say, features of the function. Let's say if we define a function, let's say we call it kids, and here we say kids, that prints the youngest kid of them. So what I want to say is that in case the user, or in case you did not know how many inputs you will have, how many arguments, how many arbitrary arguments you will have, then you can use something like this. So by adding a star next to this argument, so the argument here is kids, you can say X instead of kids. Let's say X, but you don't know how many arguments will be there. So something like kids, let's say 1, 2, and 3. So here you can define an arbitrary argument that you say, okay, this argument here, this X, it might have, or it might happen to have 100 arguments, it might have 200 arguments. So arguments is inputs in this case. So you can select one of them, let's say 5. Actually, not 5, we don't have 5, let's say 1. And define it. And then when we print it, it will take the first element, not the first element, let's say the 0th element, the first element. Why do I say this? Let's say that we define the same, but without the dots. Now, if we run the function, it will say that you got 1 argument, but you give 3. In the previous one, because we did the star, it did not give us this error. So in case you cannot, let's say, figure out how exactly or how many exactly arguments you have, then using an arbitrary argument like this will help you avoid an error. So another cool tip is the arbitrary keywords argument. So let's say we have 1 argument that can have, let's say, or 1 dictionary that have, let's say, high and low. So let's do it like this. Let's say power, and then say the lowest power is, and then here. So what do I mean by this? Let's say you have a dictionary of values where you have the high values and the low values both in the same dictionary. So we know from dictionaries there are keys, so we want to access the correct key. But it might happen that we have different keys being sent to this definition or to this function, sorry. So power in this case. So what really happens is that one, we need to add 2 stars so that it's an arbitrary keyword argument. This means that you can have different keywords inside there and you choose one of them. So how to use it? Let's say I say low equals 250 and high equals 257. So now if I define it, it will basically be sent, those low and high will be sent as a dictionary, and in there it will go to the key low. So you will get the 50. So the difference between the arbitrary argument and the arbitrary keyword argument or key argument is that this one here is sent as a tuple. So you can access the first, the second, and the third, or something like this, while this one is being sent as a dictionary. Let's say instead of low here, if we mistakenly did it as a tuple, something like this, and then we define it, it gives us a key error, which is the same error we get when we try to access a dictionary by using the index, not the name of the key itself. So this is a brief introduction to the definitions, let's say, sorry, the user-specific definitions of functions. Now there are other types of functions, for example, like lambda. So there's something in Python called lambda. What is lambda? It's basically a function in Python, a very simple anonymous function that is not defined. So if we say the previous one was power, so power is basically defined as a function. Or we had kids or MAPI or country. So these are defined. Lambda is whatever you put a function in there, sorry, is not defined. That's one thing. And it can have only one expression. So what does this mean? If you go back to the MAPI function, we basically first defined it as 0, then had a for loop to it, and then multiplied it by 100 over the length to get the average. In lambda, you can only get one expression. So as long as it's in one line, so let's say x squared plus 5 minus 2 over y, whatever you want to do it, you can, but you cannot have different steps of expression. So that's the expression. And you can have as many arguments or inputs as you want. So let's say, well, let's try to do it. So lambda, let's say x, and then we do like this. Let's say we do x times 2. So now lambda is defined. So if we say a equals lambda, a here is defined as a lambda function. So if we say a of 5, this would give us, oh, sorry, it's the power of 2. So here it will give us 25. You can even have it like this. So instead of using a to define it, you just say, okay, 5. So if you want each time to calculate the square of any number or even the cube or whatever you want to do, you can do it like this. Let's say it's a bit more complicated. Let's say we want to calculate x plus x squared plus 5. So here we say the input is only x. So x squared plus 5, and the number here is 4. So 4 squared is 16 plus 5, that should 21. So let's do a bunch of inputs. So let's say x, y, z. So we want to calculate x squared plus y to the power of 3, and both of them over z. And what are my values? Let's say 2, 5, and 1.5. So x will be 2, y will be 5, and this is 1.5 as z. If we compute it, then the result is like this. So it's a very useful function, but it can be somehow of a limited or simplified version. You cannot really go, let's say, deeper in there. It's only very limited use. So another function, if we recall the square, for example, we said this one. So let's go back here. Let's say this is a number. Instead of changing, let's say we want to put a list in there instead of one number. Instead of changing this number here, or this definition here, that it deals now with a list, we can use a function called map. So map basically takes one function, you name it whichever it is, and you insert a bunch of numbers here or there. The result would be the resulting output of that function. So something like this. It's a square, and then we put a list of numbers, 1, 2, 3, 4. So that's the results of it. If we say list of results, so to get it out, basically we got the result out. So instead of using it, or instead of changing the same function to accommodate if it's a number or if it's a list, I can keep it as a number, and then using map function, I can use the same function over this list. So it's kind of iterating in a very simple way instead of doing something more complicated. Another useful function in Python, a built-in function, is filter. So filter, from the name, it filters values to get you back to a certain criteria. So let's say we define a list, pnom, of different power plants with different values. Let's say yes. So filter, you can use it along with lambda to get somehow a filter, let's say a quick for loop or a quick selection of values without really needing a very long coding or a very long line of coding. So let's try it. Let's say that we want nominal powers that are more than 600 from this list. So how can we do it is by using filter and then lambda. And as we did before, now what is our expression? X is more than 600, we said, and then from the pnom, from our list. Now, if we do it like this, then again, we need the list to get the output, or let's say the output of it. We get the list that neglects 500, 600, and 220. So it's a very useful way of filtering data very quickly without the need of a for loop or an iteration or you name it. Let's say that we have another list. Let's say L1 equals bunch of numbers. So I want to filter this list and only get, or let's say, get everything out of this list except for the non-value. So again, we do it as we did with the filter because it filters the data based on our criteria that we set. So how to do it? Filter, and then you say, okay, my criteria is none, and use L1. So if you say the list of that, you get the same list that you had without the null number. So the filter is extremely important, and it's very handy to use within, let's say, small lines of code that it can have a big impact. The last thing that I want to discuss in this video is any and all. So there's a function called any and a function called all. So it's somehow same as the and or. So any, if you put here, say true, false, true. So if any of those is true, it will return true. So if you had, let's say, a condition where you needed one only to be true from out of a list, then you need any of, or if you use any, it's a very useful condition that you get true out of it. So let's say if any of those, then print one is true. And we know from previous videos is that we say if true, then it will execute whatever is here. So let's say, and if it was if false, then it will say, or it will not. The same thing with all. So if we say all, and then we say false, true, true, true. So this will check if all of them are true. So if in this case it's not, so it will return false. The same thing also with any, if it was, so any of false, let's say all of them were false. So and this one here, of course it's a no-brainer, so false and false and false, that's false. And if all are true, then it will return true. So that's it for this video. Thank you for watching and see you in the next video.